So here in this problem, we have three numbers a, b, c. These three numbers are in arithmetic progression. Then we need to show that b plus c, c plus a, followed by a plus b, these three numbers are also in arithmetic progression. So let's begin. Whenever we say that when a, b, and c are in arithmetic progression, that would mean they must have a common difference. Meaning, if we take b minus a, this must be equals to c minus b. Or simply put, if we have b to b equals to a plus c. Let's label this as number 1. This is what this is a property of three numbers that are in arithmetic progression. Now, we have b plus c, c plus a, and a plus b. Let's say they are in AP. We are just supposing, we will show that that this is actually an AP. So that means c plus a, this is the second term. From here, if we subtract the first term, then the common difference that we obtain, this must be exactly equals to subtracting the second term from the third term. So let's see if it is true or not. So here we have c plus a minus b minus c equals to a plus b minus c minus a. So here we have positive c, negative c cancelling out. So we have a minus b equals to, we have positive a, negative a cancelling out, b minus c. And when we rearrange this equation, we get 2 times b equals to a plus c. So that means we have actually shown that when b plus c, c plus a plus b are in AP, then we get back the condition that a, b, c are in AP. Let's move on to the next problem. Problem number 2. Again, we have the same numbers a, b, and c that are in AP. Then we need to show that these three numbers are also in AP. So let's begin. So first, we will suppose that they are actually in AP. That means we have a squared times b plus c and b squared plus c plus a, comma, c squared times a plus b. These three numbers are in arithmetic progression. And if they're in arithmetic progression, that it must mean that then the common difference must be the same. That means if we have b squared times c plus a, this is the second term. From here we are going to subtract the first term, then this common difference must be equals to, we'll take the third term, which is c squared times a plus b. From it we subtract the second term, that is b squared times c plus a. Now further simplification is going to give us b squared times c plus b squared times a minus a squared times b minus a squared times c equals to c squared times a plus c squared times b minus b squared times c minus a b squared. Now what we can do here is, if we take c as the common factor, we'll combine the first term and the fourth term by taking c as the common factor. We have c times b squared minus a squared. And from the second term and the third term, if we take b times a as the common factor, this will get multiplied to b minus a, which will be equals to, now we will take a as the common factor and combine the first term and the fourth term. So we'll have a multiplied to c squared minus b squared. And from combining the second term and the third term by taking cb as the common factor, we have c minus b. Now we know that b squared minus a squared, this is simply b minus a times b plus a, plus ba times b minus a, which will be equals to a multiplied to c squared minus b squared, can be written as c minus b times c plus b, plus cb multiplied to c minus b. Now we have two terms on the left hand side. From the two terms we can take b minus a as the common factor, where b minus a multiplied to, so from the first term we'll be left with c times b plus a, which will be simply cb plus ca, plus from the second term we have taken b minus a as the common factor, we'll be left with ba. This will be equals to, now on the right hand side we can take from the two terms c minus b as the common factor. So c minus b will get multiplied to, so in the first term we're left with a times c plus b, so that's simply ac plus ab. And from the second term we are left with, since we have taken c minus b as the common factor, we are left with bc. Now you can see that cb plus ca plus ba So this and this particular term will get factored out on both sides, and that leaves us with b minus a equals to c minus b. So this means that a, b and c, these three numbers are in arithmetic progression. So we started out with the assumption that these three numbers are in arithmetic progression, and we found out that if this is true, then ABC must be also in an arithmetic progression. Hence, we can say that this is indeed in arithmetic progression whenever we have the condition that ABC are in AP. So let's move on to the next problem. Problem number 3. So here it's given that if ABC are in arithmetic progression, then it follows that 1 over BC, 1 over CA and 1 over AB, these three numbers are also in arithmetic progression. So let's begin. So first we will consider that these three numbers, 1 over BC, 1 over CA and 1 over AB are in AP. So this is an assumption. Now we're going to use a fact, a property of arithmetic progression, which states that let's say we have three numbers A, B and C that are in arithmetic progression. Now if we multiply each of the numbers by some constant alpha, where alpha times A, comma alpha times B, comma alpha times C, then multiplying with this constant number, these three numbers are still going to be in AP, where alpha, let's specify, where alpha is a constant. So that means multiplying with a constant number does not affect the progression of the three numbers. They are still going to be in arithmetic progression. So what we'll do, we'll multiply these three numbers with A, B, C. So we can say that ABC over BC, ABC over CA and ABC over AB, these are also in AP. Now what is ABC over BC? That's simply A. ABC over CA, that's B, and ABC over AB, that's C. So these is also going to be in AP. So hence we have shown that if 1 over BC, comma 1 over CA, comma 1 over AB, these three numbers are in AP, then ABC are in AP. If you happen to forget this particular property, you can also go the usual way. That means if these three are in AP, then we can also show that the common difference, that means 1 over CA minus 1 over BC, thus must be equals to 1 over AB minus 1 over CA. We can combine the two terms, so the common denominator is going to be ABC, and in the numerator we are going to have B minus A. So this will be equals to, combining the two terms on the right hand side, we have a common denominator of ABC. In the numerator we're going to have C minus B. Now ABC, that gets cancelled out, and this is going to give us B minus A equals to C minus B, which only shows that A, B, C are in arithmetic progression. Let's move on to the next problem. So problem number 4. We have to show that these three numbers are in arithmetic progression. So let's begin. We'll begin by considering that these three numbers, 1 over square root of B plus square root of C, the next second term, 1 over square root of C plus square root of A, and the third term, 1 over square root of A plus square root of B are in AP. If they are in AP, then this must mean that we have 1 over square root of C plus square root of A minus 1 over square root of B plus square root of C. This will be equals to 1 over square root of A plus square root of B minus 1 over square root of C plus square root of A. Now let's combine the two terms. So we have a common denominator, square root of C plus square root of A, multiplied to square root of B plus square root of C. And in the numerator we're going to have square root of B plus square root of C minus square root of C minus square root of A, equals to, combining the two terms on the right hand side, we have a common denominator, square root of A plus square root of B multiplied to square root of C plus square root of A. And in the numerator we're going to have square root of C plus square root of A minus square root of A minus square root of B. Now on the left hand side, in the numerator we can cancel out square root of C and negative square root of C, and on the right hand side we can cancel out square root of A and negative square root of A. So this is going to give us square root of B minus square root of A in the numerator, and if we compare the new denominator on both sides, we see that square root of c plus square root of a, this will also get factored out. That means we have in the denominator square root of b plus square root of c equals to, and on the right hand side in the numerator we have square root of c minus square root of b divided by the denominator, which is square root of a plus square root of b. Now let's cross multiply. So here the numerator square root of b minus square root of a can be also expressed as negative times square root of a minus square root of b. This is multiplied to square root of a plus square root of b equals to, then the expression on the numerator of the right hand side can be also expressed as negative times square root of b minus square root of c times square root of b plus square root of c, which will be, now this is an identity which can be expressed as square root of a whole squared minus square root of b whole squared equals to negative times square root of b whole squared minus square root of c whole squared. Further simplification is going to give us negative of, so square root of a whole square, that's simply a, so we have a minus b, this will be equals to negative times b minus c, or we have b minus a equals to c minus b, or simply put we can say that a, b and c, these three numbers are in arithmetic progression. So hence we have successfully shown that when a, b, c are in AP, this would mean that these three numbers are also in arithmetic progression. Let's move on to the next problem. So here we'll need to show that these three numbers are in arithmetic progression. So we'll suppose that they are indeed in arithmetic progression. So we have a times 1 over b plus 1 over c, the second term being b times 1 over c plus 1 over a, and the third term being c times 1 over a plus 1 over b. So let's say that these three numbers are in arithmetic progression. Now, using the fact that the second term, which is b times 1 over c plus 1 over a, minus the first term a times 1 over b plus 1 over c, this must be equals to c times 1 over a plus 1 over b minus the second term, which is b times 1 over c plus 1 over a. This will be b times, so here we have a plus c divided by ac minus a times c plus b divided by bc equals to c times b plus a divided by ab minus b times a plus c divided by ac, which gives us, now we have AB plus ABC divided by AC minus AC plus AB divided by BC, which will be equals to BC plus AC divided by AB minus AB plus BC divided by AC. Fine. Now we'll combine the two terms on the left hand side. So we have a common denominator of A, B, C. Now in the numerator, we'll have b times ab plus bc minus a times ac plus ab, which will be equals to abc in the denominator, and in the numerator we have c multiplied to bc plus ac minus b times ab plus bc. This is going to give us ab squared plus b squared c minus a squared c minus a squared b whole divided by abc, which will be equals to bc squared plus ac squared minus ab squared minus b squared c whole divided by abc. We can cancel out the abc from the denominator of both sides, and then we will combining, we'll take AB as the common factor. So here we'll have b, and from negative a squared b we'll have a, plus we're going to take c as the common factor and combine the second and the third term. So it's going to give us b squared minus a squared. Next, on the right hand side, we're going to combine bc squared and negative b squared c by taking bc as the common factor. So we have c minus b. Plus, we're going to combine the second and the third term by taking a as the common factor. So we have c squared minus b squared. Now let's further simplify. So we will have ab multiplied to b minus a plus c times, so b squared minus a squared is simply b minus a times b plus a equals to bc multiplied to c minus b plus a times, so c squared minus b squared, that has the factor c minus b times c plus b. Now here we have two terms on the left hand side. Here we can take b minus a, these as the common factor, by b minus a, so we'll have b minus a multiplied to, from the first term we'll be left with ab, and from the second term we'll be left with c times b plus a, so that's simply cb plus ca, which will be equals to, on the right hand side we can take c minus b as the common factor from both of them, so we have c minus b multiplied to, so from the first term we have bc, and from the second term we have a times c plus b, so that's ac plus ab. Now we can have these two terms factoring out from both sides, and this leaves us with b minus a equals to c minus b, and this relation tells us that a, b, c are in arithmetic progression. So that means we have successfully showed that whenever we have the condition that a, b, c are in AP and an arithmetic progression, then these three numbers must also be in arithmetic progression. Let's move on to the next problem. So here in this final problem, we need to show that the given three numbers are also in AP. So let's begin. So we'll start off with our expression. So here, let us suppose that b plus c whole squared minus a squared, then the second term, which is c plus a whole squared minus b squared, and the third term, a plus b whole squared minus c squared. These three numbers are in arithmetic progression. Now since what we'll do, we will expand these expression, each of these expression. So here b plus c whole squared minus a squared, this is b plus c plus a multiplied to b plus c minus a. Then we have the next expression, which is c plus a plus b multiplied to c plus a minus b. Then our third expression is a plus b plus c multiplied to a plus b minus b. So this is also in AP. Now we can see that there is a common term here, so it is b plus c plus a, b plus c plus a, b plus c plus a present in each of the three terms. So what we can do, we can divide each of them with a plus b plus c, and the number which are left behind, that is b plus c minus a, c plus a minus b, and a plus b minus c. These are still going to be in AP. So here we are using the property of arithmetic progression, that means dividing by a scalar number or a fixed term, there still the numbers are going to be in arithmetic progression. Now we can use the property, that means we'll consider the second term, which is c plus a minus b, and from it we are going to subtract the first term, that's b plus c minus a. So this is equals to the third term, that's a plus b minus c, and from here we are going to subtract c plus a minus b. Now let us further simplify. So we have c plus a minus b minus c plus a, which will be equals to a plus b minus c minus a plus b. Now we can cancel out few terms. So here positive c and negative c cancels out. Then on the right hand side we have positive a and negative a cancelling out. Fine. So that means we have 2 times a minus 2 times b, that's equals to 2 times b minus 2 times negative 2 times c. Or what we can do, we can take negative 2 as the common factor. This will be negative 2 times minus b minus a equals to negative 2 times c minus b. Now we can divide both sides with negative 2. This is going to give us b minus a equals to c minus b, which simply means that a, b, c are in arithmetic progression. So that means if we have a, b, c in arithmetic progression, then it follows that these three numbers must also be in arithmetic progression.